Mirror should be turning on soon. I got it all fixed. Sure. Oh, because you don't have yet. All right, kiddos. Linear. Give me some examples of linear functions. Go. Sure. Y equals. I forgot. My smart board's not happy today. Okay. Old-fashioned one. Okay. Y equals x. What's another linear function?
Y equals mx plus b.
Mx plus b. Sure. So y equals what? 2x minus 1? Oh yeah, you can do a napkin or there's like a tissue in the basket unless it's empty. How about 3x plus 2y equals 5? Is that a one?
That's standard.
It is standard form. Right? ax plus by equals c. We could do point slope form, but whatever, you guys get the idea. Lines, what does it take to have a linear function? X's and y's both need to be only to the first power. Booyah. Non-linear functions. Everything else? How about y equals e to the x? How about x squared plus y squared equals 4? Ooh, that's a circle. How about y equals 1 over x plus 2? Okay, we have tons of nonlinear functions. We have rational ones. We have quadratic or cubic or quintic or etc. Other polynomial ones. We have exponential. We have logarithmic. We have trigonometric. Oh my goodness. So long story short, which types of equations would make the easiest system to solve? System of equations. You have more than one, yeah? You have to put it all together and say, hey, what do they all have in common? True? Yeah, linear is definitely the easiest. We're going to start here, and then we're going to maybe build up to there. Nonlinear, to be honest, unless they're very, very similar equations that are together in a system, you'll probably be using a calculator. Because to compare an e to the x to like a sine of x, yeah, no, we don't have mathematical ways of, by hand, doing mental math with exponentials and trig in the same system. That's a bad idea. But if we have multiple equations that are both exponential, maybe we can do something. Or multiple equations that are both quadratic, maybe we can do something, etc. So if they're similar to each other, we're okay. If they're non-similar, you're probably using your calculator, probably graphing and finding intersections, etc. Long story short, a solution to a system is an order that satisfies each equation in the system. It can also be seen as the intersection with, let's say, the intersection of all the functions. I'll just say of all the equations, because maybe some of these, like the circle, won't be an equation. Or, I apologize, won't be a function. It would just be a relation. So we know systems of equations have more than one. They can have 2 or 3 or 4 matrices. Are they coming? Anyway, multiple equations. In order to find a solution, it has to be true in every single one, and graphically that would be an intersection. Cool kids, if you get an example like this, where it literally just says, check a solution. Wait a minute, what have they just given you?
Plug it in.
Yeah, they just gave you an answer and said, hey, does it work? It's so easy, it's hard. Because some of you are like, wait, check it. Basically, you just take it. That's not working because my pen tray isn't working. Anyway, I apologize. One more?
It doesn't work.
Sure. Now, could you make this plugging in and checking last a really long time? Yes. Does it need to? No. Why? Because you're pretty good at mental math. You're an honors pre-calc, for heaven's sakes, right? So could most of you plug in and be like, hey, 2 times 2 is 4 plus 1 is 5, check. 3 times 2 is 6, 6 minus 2 times 1 is 4, check. Yeah, but the idea is, in order for a solution to be true, in order for a solution to work for an entire system, it needs to be true in both equations. We get the idea, right? Check it, plug in. When you plug in, it works in both. That's the idea of how to solve a system, yeah? Okay. So with that, let's review substitution. You're like, wait, substitution's easy. Just say plug it in, right? Well, yes and no. All at the same time. Do you have to write it all down? No. What do you need to write down? Something new, something different that you wouldn't have thought of. Substitution, plug it in, that's what I say. However, one of the trickiest topics in Algebra 2, go back to Algebra 1, Algebra 2, and Pre-Calc. One of the trickiest basic concepts that I have to come up against every year, domain and range, yes. Factoring, yes. Foiling, yes. Killing the poor woodland creatures, yes. But function notation. Always have to go over it again and again and again and again. How do you do f of 2? How do you do f of x squared? How do you do f of x minus 1? How do you properly do? So even though substitution at its core is supposed to be easy, even yesterday I was a kid taking a test. Looking at, you guys remember all the trig formulas, right? The sheet of trig formulas for chapter 5 and like the T-foods and all that jazz, you don't make it up. What did we do with those formulas? We substituted. We said, hey, we see a sine of 2x, and oh, there's a better formula for that, the double angle formula. Let's substitute. Let's take out this guy, let's put in that guy. So many of you are athletes. You know substitution. A person comes out and a person goes in, right? And why is it so hard? I don't know, but it is. Anyway, so basic, and yet, my poor little pre-calc kid yesterday, the idea of taking one out and putting one in with trig was just not working. It was a struggle. Solve one of the equations in terms of the other. Substitute into the other equation. Just a few of you make way too much work on yourselves because you don't remember where to plug it in. So when you have a system of equations, you solve, you pick one, probably the one that's easiest to solve for a variable. Pick one, solve for a variable, plug into the other. The point is plug into the other equation. If you plug into the first, everything's going to cancel and it's going to be very, very sad because you won't know anything. Number 3 says, hey, once you plug into the other, hopefully, now you get an equation in terms of one variable. Then solve. So solve one for one variable, plug into the other, solve the equation that you now have, hopefully in terms of only one variable. Here's a snazzy word that you guys might not have used before, but you should know the idea. Back substitute. What does that mean? Go back and plug in. It's as easy as that. But when the book says it, just want you guys to know. Back substitute. Go back and plug it in. And then check. Why do we say check? Because every now and then, you guys know, because of the math, hopefully you know, we have to check for, what's the word for that special type of solution that looks like it should be true, but it's actually impossible from the get-go?
Extreme.
Yeah, check for those extremes. Especially with, let's see, extraneous solutions will never occur unless you have some sort of function with a limited restricted domain to begin with, like a logarithm, or a square root, or a denominator. Maybe a trig, but I don't think I've ever seen it with trig. But a logarithm, a square root, or a denominator. We have to be careful that something illegal didn't sneak in when we were canceling and doing inverse operations and ignoring some of those functions that originally would have been restricted. How could I expect you to solve this system of equations by hand? Ooh, by hand? But wait, you just said when the two equations are very, very different, we almost always get to use our calculator.
Almost always.
Almost always. How should you be able to solve this by hand?
Undo the log.
Under the log. And Andrew, why did you go straight to that equation and not even look at the first one?
The first one has a y too.
The first one has an x and a y, the second one has... So is there strategy as to who you choose to solve for one variable and plug into the other? Yeah. This one says, hey, can't you solve for x? And then can't you back substitute? Go to, how do I get rid of the log?
Make everything e, exponent of 10.
Exponent of 10. Why not e? It's a common log. Careful. It's a common log. Common log has a natural base of, sorry, that could be confusing. A common log has an understood base of 10, yeah? So 10 to the power of log base 10 gets you? Are we okay? Is it just Friday and we're tired? We're just going fast, we're overwhelmed.
It's weird.
All the above?
Yeah, we're just.
Okay, when I was driving this morning, I was just like, oh my goodness. I'm here.
It's 3 in the morning, I feel alright.
Okay, 10 to the power of log base 10 cancels out. E to the power of log base e, 2 to the power of log base 2. Remember, they're inverses. Cancel. Okay. So, who do I have? 30? No. 3/10? No.
1,000.
Good. We know this is a power, right? And now that we know that x is 1,000, now that we have solved one, plug into the other, well, I guess we're not even back substituting. We're just substituting. This is our first plug-in, right? Take x equals 1,000. 1,000 takes the place of?
Yes.
Told you it was an easy section, right? Plug in. Square root of, it's not that bad. 1,000 plus y equals 2. Now what? Square both sides and then subtract. But good job that you guys were doing all the mental math. Right? So we have 4 minus 1,000, so y is equal to, sorry, when I have to do it this way because the pen tray is not working, everything is lagging. Anybody who does anything with technology, lagging is super annoying. Subtract 1,000 from 4. So if I try to be like, oh hey, now it works nicely. Anyway. Gonna have to do this. I should not have done that. You guys see it lagging though, right? Like mine's going down when it's still going up. Anyway, that's the struggle. Okay, let's keep going. Ooh, hey, okay, so some of these will be exciting. They're not gonna be totally boring. How have we solved number 11? Not in algebra 1 anymore. What do we do?
The y squared and take the square root.
Oh, I guess we could, but that doesn't sound very strategic. I'm not sure if I want to solve this guy for a square root when I can just solve this guy for a normal. But maybe that's just me. But first of all, let's be real. Can we be real? Who likes the fractions? Nobody. So what am I going to do to the entire equation to say, fraction, bye-bye. Multiply both sides by 2, by the common denominator. So I can say, hey, instead of taking the first 2, let's just cut off that first one and say I don't like you. I'll take an equivalent form of him, which is going to be negative x plus 2y equals negative 5. Is that nicer? Yeah. Go team.
You did 2.
I had to distribute the 2 to everything. So I'm multiplying 2 basically by both sides, if you want to think of it that way, and I have to distribute when I go. Is that cool? It's just a simple way. It's kind of like my shortcut of multiplying top and bottom for complex fractions. I don't know about you guys. I think solving for x is the easiest. Is that okay if I go that way?
Yes.
Okay. So if I solve for x, I'm going to go ahead and move the 2y to the other side, which will be negative 2y. Divide everything by negative. I get x equals 2y plus 5. And what am I going to do with that guy? Yeah? So, pick an equation, solve for one variable. I did plug into the other equation. So far I'm doing steps 1 and step 2. I end up with 2y plus 5 quantity squared plus y squared equals 25. See that line? I did it twice. Now what? Yeah, square it legally though, not killing a puppy, true? So we end up with 4y squared. Who's mental math in it for me? Plus?
Y squared.
Plus 20y.
And then plus 25.
Plus 25 plus y squared equals 25. Let's see, the 25's cancel, yeah? And then my 4 and 1 make 5y squared. So then I have 5y times y plus 4. You guys have checked my math, right? We're okay? Y equals 0 and negative 4. 2 answers? What? Now, at the very beginning, the directions did say check graphically. Do you guys, 45 what? What's wrong? 0 and negative 4, right? We set both equal to 0. If you graph your line linear function and your circle with a radius of 25, how many intersections are we going to end up having?
2.
What do the y values end up being? 0 and a negative number. Does that seem to make sense with what we just solved? How am I going to find the x's? Back substitute. This is what back substitute means. It means, hey, you already solved for one, you plugged into the other, you simplified, good. Go back and say, hey, there's an expression just waiting for me to plug in. Because I already know that x is equal to double the y plus 5. So let's go ahead and double the 0 and add 5. That's 5, right? Let's go ahead and double the negative 4 and add 5. Negative 8 plus 5 is negative 3. So what are my solutions? 5. Hold on, pause. Did I do my doubling and adding bad? Something happened. It was bad. No, that's good. Yeah. My point is 5, 0. And my point is negative 3, negative 4. There you go. It'd be the same thing as if I had done the intersections when looking at the graphs. Same thing as if I had done the intersections when looking at the graphs. Pause. What would you have had to have done if you wanted to get these graphs from your graphing calculator and not just do y equals mx plus b and x squared plus y squared is r squared? You can't put it into your calculator until... Yeah, I'd have to get y by itself. I'd have to add the 1/2 x and then I'd have to plug it into y1. I'd have to subtract the x squared and plus or minus square root. Wait, how do you put in a plus or minus square root to the calculator? There's no button. There's no feature. So how many answers are there with plus or minus? 2 of them. So you would need to do y2 and y3. One of them with the positive square root, the top half. One of them with the negative square root, the bottom half. I don't know about you, that sounds harder than just graphing it, but maybe that's just me. Cool kids, number 22, no circle. Go team. Ah, but fractions, but pause. What did we just say you could do if you have a huge aversion to fractions?
Multiply.
Yeah, you could multiply the top one both sides by 4. That would get rid of the 2 and get rid of the 4. I can multiply the bottom one, everybody by 4. Does that mean you have to? No. Could you? No. Now technically, this does say solve with substitution. So in a way, it might not be the easiest thing for this exact example, for these exact directions to get rid of the fractions. If this was an elimination one, I'd say totally get rid of the fractions. That way you can much more easily match them up and then simplify. But technically right now, if I had used substitution, which, okay, the book is going to give you, you guys know, both of them can solve, but let's just say we had to. Wouldn't you just solve for y right now?
Yeah.
I mean, that's what I would do. If we had to do substitution, maybe not even change anything. Solve for y, add the y, subtract the 4. Go plug it in to substitute. You would end up with 1/2 x Now maybe right now you'd want to get rid of the fractions and that wouldn't be an awful idea. Some of you would do it quite illegally though, if I just said get rid of the fraction right now. So I'm going to go ahead and distribute first so that you can avoid that illegal. Some of you would want to multiply here and here and here and here and here, and that would be horribly wrong. Because once you multiply by the coefficient, there's no need to go inside, it will distribute, but anyway. I'll go ahead and just minus 3 equals 10. If you really hate fractions, you can multiply both sides by, why am I choosing 16? Yeah, get rid of that denominator. When I multiply 16 by 1/2, I get 8. When I multiply 16 times, I get 9x. 16 times 3. 16 times 10 is 160. So I don't know, it's a toss-up. One way you have fractions and the other way you have big numbers. It depends on where your weakness lies, I guess, huh? At this point, 17x equals, adding 148 would be 208. 17 goes into 21 times, 38. Ooh. Well, that's a bummer. Seventeen is in 21 times. You guys double check my math, is it a nasty fraction? Could be. It is. Alright, well, it is what it is. We have x. Now it's time to, I would say, back substitute. What am I talking about? There's an equation, just screaming to be plugged into. I know that y in terms of x is 3/4 x minus 4. So I need to go ahead and just plug that in. So I would do y equals 3/4 times 208 all over 17 minus 4. Ugh. It's not very pretty, but I think it's right. 400, 208, that simplifies a little bit. That'd be 52. 3 and 52 would be 156 over 17. If I get common denominators with the 4 times 17 is 68. When I subtract the 2, 56 and 68, there's a difference of 4 and 12. Oh, because I did not write the 17. I wouldn't even pay attention to that thing. Sorry, there's a difference of 4 and 8 is 12, so that'd be 88 over 17. Maybe double check that one. Did that a little fast. 140, 156, I think that works. So your final solution is, wait, why does this make sense that there's only, I know it's nasty, but why does it make sense that there's only one point of intersection?
Linear.
Yeah, two lines can only intersect in none parallel. One or infinitely many. Right?
So basically, subtract
I got a common denominator with the
4.
common denominator, then I just put them together. All right, cool kids. I think a few of you guys are still writing. Let me dual page and see what's coming next. Oh, a work page for us to actually have room to work. Well, that was fun. Okay, bye. Wait, ooh, what's this page talking about? Solve graphically and then use a grapher. Oh, and then word problems. That's just homework help. You don't need me to just do that. All right. We'll put them up there just so you guys can see them. But pause, graphically, what's it saying? Get a graph of a circle with a radius of 5. Guys, it's minimum date and you're stealing my last couple minutes. I have this guy's a circle, radius of 5. I got him. How am I going to do this guy? 2c. If I need to move it to the other side and I get 3/16 x squared. Who's that? Isn't that going to be a parabola? How many intersection points am I going to have? 2. How am I going to find them? There it is. I'm not sure the graph's going to get me there unless I use my graphing calculator. What am I going to do when I get to my graphing calculator? Find the intersections. And if you're like, ew, gross, who wants to solve for y? I guess you could kind of cheat and just go do some substitution magic. But how about this one? Why does it say to use the grapher? It's saying for sure, use your graphing calculator, no ifs, ands, buts about it. If I solve for y, I would end up getting x plus 1. Well, kiddos, I don't know how to resolve that. I get e to the x equals x plus 1. I need to graph y1 and y2. And what am I going to use? Intersections. We could use ln, but the problem is x is stuck again. There's no mathematical by hand way at this level to solve. Kiddos, playground homework is due on Monday. The one thing we didn't talk about was what to do when words come, but you guys have seen words before. You got it.
No.
Adios, one more
I
nutrition.
mean, we only have like another 25 minutes till nutrition. It's not like.
I know, hang in there.